Okay, let's dive right into this explainer. We're looking at exactly why quantum laws completely defy reality. We walk through life assuming the universe just makes sense, right? That it follows a neat, predictable script. But when we actually dig into the raw data from the world's leading physicists, we find that the very fabric of our universe is literally glitching. It's glitching in ways that challenge our absolute deepest assumptions about space, time, and existence itself.
Right now, you're relying on the physical world being solid. You expect it to be governed by strict rules. You assume the chair you're sitting on is fundamentally there, right? Anchored in reality. Well, by the end of this explainer, I guarantee you're going to view everything around you with a profound sense of wonder and honestly, maybe a little bit of existential dread. We're about to look at phenomena that literally shouldn't be possible, yet are happening all around you, right at this very second.
We just assume the universe operates on the firm, reliable rules of classical physics. In that world, there is clear cause and effect, a straight line from A to B. But the undeniable data we're unpacking today shows that, at a fundamental level, reality operates on quantum mechanics that totally defy all classical logic. We're talking superposition, time-bending anomalies, and particles that just flat-out refuse to obey the most basic rules of math.
Section 1. Biological glitches. Quantum life.
So, for a long time, scientists thought quantum weirdness could only exist in these super-cooled, highly controlled laboratories. Definitely not inside warm, messy, living things. But in 2007, Professor Graham Fleming's research team over at UC Berkeley looked at how energy moves through plant leaves during photosynthesis. They were totally expecting to see a standard, clunky chemical transfer of energy. Instead, they discovered that when sunlight strikes a leaf and energy enters those photosynthetic proteins, actual quantum coherence pathways open up. The system literally exists across multiple pathways at the exact same time just to find the perfect, most efficient route. And what makes this discovery truly impossible is the timing. In a warm, chaotic biological cell at room temperature, quantum coherence should logically collapse in a femtosecond. To put that into perspective, that is 1/quadrillionth of a second. It's entirely too short to be of any biological use whatsoever. Yet, the Berkeley team found it lasted up to picoseconds, thousands of times longer than expected. So every leaf outside your window right now is quietly running a perfectly optimized quantum machine that totally surpasses all human-made technology. This biological glitch perfectly aligns with MIT physicist Jeremy England's 2015 framework. For the longest time, biology viewed life as this anomaly constantly fighting against thermodynamic decay. But England's equations proved that life itself is actually thermodynamically inevitable. When atoms are subjected to a sustained energy source, like starlight, and surrounded by a heat bath, they will automatically reorganize to dissipate that energy more efficiently. You aren't just a cosmic accident, you're the universe's ultimate entropy-generating strategy. Basically, you're what a rock irradiated by starlight inevitably becomes.
Section 2. The observer problem. Watching alters reality.
All right, let's see how this builds into something even stranger. In classical physics, seeing an object requires interaction, right? Light bounces off a chair and hits your eye. No interaction means zero information. But in 1994, a team led by Paul Kwiet at the Los Alamos National Laboratory proved a concept called interaction-free measurement. Using a really sophisticated device called an interferometer, they successfully detected the presence of an object blocking a path with over 85% accuracy, without a single photon actually touching the object. Information was gathered without any physical energy signal bridging the gap. So what exactly is observing the world around us without leaving a single trace?
Oh, and it gets weirder. We used to think observing a system might freeze it in place. That's the so-called quantum Zeno effect. But in 1992, theoretical calculations revealed the quantum anti-Zeno effect. If we track a system continuously at dense, hyperspecific frequencies, the sheer act of watching actually forces the system to decay and transition significantly faster. By simply looking at an appropriate frequency, we don't just passively observe reality, we aggressively force it to decompose and change. This brings us to the monumental 2011 PBR theorem. For decades, physicists went back and forth over whether the wave function, which is the mathematical probability of where a particle might be, was a real physical thing or just a measure of our own human ignorance. Well, the PBR theorem forces us to accept that the wave function is a real physical state. This means the objects right in front of you truly exist in a state of probability superposition until a measurement or observation physically triggers a reality collapse. The weirdness isn't just in our heads, it is the foundational structure of the physical world outside.
Section 3. Breaking math and logic. Equations stop working.
Let's step away from biology and observation for a second. The pigeonhole principle is one of the oldest, most undeniable laws of mathematics. It basically says that when you place 3 objects into 2 boxes, at least one box must contain 2 objects. I mean, it's basic, immutable counting. Yet in 2016, a research group led by physicist Yakir Aharonov completely shattered this law. Using incredibly delicate weak measurement techniques, they successfully placed 3 quantum particles into 2 boxes.
Now, the crucial point is what they found inside those boxes. They recorded 0 overlap in 100% of the trials. No 2 particles shared a single box. All 3 particles were in completely different boxes simultaneously. Deep inside your body right now, microparticles are quietly violating the most fundamental mathematical laws of counting. Absolutely mind-blowing.
Similarly, we just expect an object to carry its own properties. A ball's mass is wherever the ball is. But the 2013 quantum Cheshire cat experiment threw that entire concept out the window. Researchers successfully sent a physical neutron down one path of an interferometer and sent its magnetic moment, which is the core property tied to the particle's spin, down an entirely different path. They literally proved that an object can be entirely separated from its own essence. Imagine a world where your mass can just detach from your physical body. Nature is entirely capable of pulling essence and object apart. As if breaking counting and separating properties wasn't bizarre enough, consider the quantum Mpemba effect. Classical logic dictates a pretty self-evident rule. Starting closer to your destination means you arrive faster. Makes sense. But in 2020, physicists predicted, and later confirmed with trapped ions, that a quantum system starting deliberately farther from its final equilibrium state will paradoxically reach that state faster than an identical system starting closer. The future of a system isn't governed entirely by where it is right now, but by the historical pathway it took to get there.
Section 4. Rewriting past and future. Time-bending anomalies. If breaking math wasn't enough, prepare yourself as we step into our final anomaly. The 1999 quantum eraser experiment fundamentally challenged the flow of time itself. They shot entangled photons through a system. In the past, the signal photon hit the first detector and recorded its physical mark. In the present, its entangled partner continued to travel. But here is the crazy part. When scientists erased the path information of the partner photon in the future, it retroactively changed the physical interference pattern that the first photon had already recorded in the past. An action occurring in the future physically rewrote a truth that had already happened. No way around it.
And this brings up a terrifying bias in how we view our entire timeline, known as the anthropic shadow. Discovered in 2010 by researchers at Oxford, this principle points out a massive survival bias in our reality. We calculate the historical risks of apocalyptic events using data, right? But civilizations wiped out by catastrophes don't leave anyone behind to record them. Our entire data set of reality is filtered through an absolute selection bias. We only have the data because Earth miraculously survived. The true timeline of apocalyptic risks is hidden from us because we're blinded by our own existence. Section 5. The true nature of reality. What does it mean?
Okay, let's bring all of this together to confront what these anomalies actually mean for the world you inhabit. We've looked at the hard data, from birds navigating via quantum entanglement in warm biological systems to the fact that passive observation actively forces physical matter to decay. We've seen that 3 objects can occupy 2 boxes with 0 overlap, breaking fundamental math. And we've seen that a future choice can reach back and literally rewrite a recorded past. Our universe is simply not the safe, predictable, linear classical machine we were all taught in school. It is deeply, fundamentally entangled, probabilistic, and honestly just strange.
So, I want to leave you with this. If the basic mathematical laws of the universe and the linear flow of time itself are just illusions waiting to be collapsed by the sheer act of your observation, how much of your future is already predetermined by rules we can't even see? Are you merely a cosmic accident, or are you the inevitable, beautifully optimized outcome of a universe that exists simply to look back at itself? Think about that the next time you sit in that completely solid chair. Until next time, keep questioning what you think is real.